Hey there, fellow retro tech enthusiasts. It's Vicky here and, today, we're going to expand on our last video, and port our silly fortune teller program from QBasic to the BASIC found on the Commander X16. The Commander X16 is a modernized system built around the 6502 processor. It was spearheaded by the 8-bit guy right here on YouTube, but also many other people to help make his dream come true. Be sure to check the description for links for the Commander X16 as well as see this code on my GitHub repository. It's a fantastic story and, while I don't have a physical device, I've had lots of fun in the emulator available for free download. Anyway, let's get started, shall we? Supporting this program isn't difficult, but there are a few minor changes that need to occur before we can port it. Let's just start with the first line, shall we? CLS. Oh, did you see that? It performed it right away. That is because, in this context, we are issuing commands directly to the system. While this is a modern system, this is how a lot of systems worked with the built-in BASIC interpreters. Anytime you type a statement, it just does it. Just like that, we told it to print, so it did just that. In order to get it to register this statement as a part of the code, we have to actually tell it the line number. Let's add this print statement to our actual code. Great, it didn't run it. We can confirm that the line exists by running the list command. As you can see, our first line is that print command. Let's go ahead and run the program by typing run. It works. But wait, where is our CLS line? Our original program clears the screen first. But how do we add it? Maybe we should just try what we did before? Okay, now let's see our program. Our print statement is gone. This is because when we give it the line number we overwrite whatever is currently set to that line. This means that if you need to add a line somewhere, you end up rewriting your code either until it gets back where it is in order, or all the way to the end. Because of this, the recommended practice is not to start at line 1 and count up, but start at something else and increment. The most common preference is to start at line 10, and increment by 10 for each line. Now, if we type list to see our program has 3 lines of code. While having line 1 still there doesn't hurt anything, let's go ahead and clean our code up and remove that. It's easy enough, we just tell BASIC that line 1 is nothing. Now let's look at the program again. That looks good for me. Let's just run it and see if it runs as expected. I think we're moving on the right track. It cleared our screen then typed our header. Now that we have this basic understanding of how this variant of BASIC operates, let's go ahead and continue porting our program. The next 2 lines are simple enough. We start at line 30 and keep moving forward with the print statements. Now we're going to ask for input from the user. If you watched my last video, you'll remember that we had to debug these input lines due to double question marks. We fixed this by changing some semicolons into colons. While it is possible to do this in this variant of BASIC, it's a little more on the advanced side. That being said, we're going back to the semicolon and allowing BASIC to print the question mark and space. Having input this line, I did want to point out the fact that we also changed the variable name. One limitation of any variant of BASIC that operates like the Commander X16 variant is that you are limited by how long your line can be. This is also true in other variants, such as QBasic, but the limit is much, much higher. I can't seem to go beyond the length of the column count for the Commander X16, 80 columns specifically, but I didn't test too much to see if I could surpass that limit. All the same, there is no scrolling here as we saw in QBasic. So it's important to take additional steps to try and produce clean code. Alright, the first section of our code is complete. I like the saying, test early, test often, so let's just do that. Let's type the run command and see how well it works. Alright, we have our header, now let's type our name, Vicky. My favorite color is purple. And my favorite animal is an alligator. If you saw my last video, I was right, you saw it later. It seems like it worked out pretty well here. Let's keep going with our simulated processing. Our for loop is pretty much the same too. As you can see, if we already know where code will go, we can go ahead and put it there. Our following line, on 110, is pretty much the same too. Now we're at a crossroads. The sleep command, while available on the Commander X16, doesn't exist in every BASIC variant. But, let's test it out. Let's see what the command, Sleep 1, will do here. Well, that certainly felt faster than a second. That's because this sleep doesn't sleep for seconds, but for vertical sync events, or what you could consider a frame. So, now we'll wait for a total of 300 frames to occur, while printing a dot every 60 frames. It works, but I want to make something that might be easier to port to other platforms later. Let's go ahead and build our own sleep command that's cross-system compatible. Seems simple enough, right? Basically, we're doing nothing 8,000 times. But why 8,000? That seems like an oddly specific number. It's because this loop takes approximately 1 second to complete on the Commander X16. However, if we ported this to the Commodore 64, we'd change that 8,000 to 1,000. Otherwise, it would take about 8 seconds to complete. This is due to the speed of the processor. The Commodore 64 runs roughly at about 1 MHz, or 1000 kHz, while the Commander X16 runs at roughly 8 MHz, or 8000 kHz. That's where these numbers come from. Now looking at our program, I did just want to point out that CLS, or our line 10, is also not on every variant of BASIC. That's fine here as we're trying to keep this as simple as we can today, but if we port this in the future, we'll look at screen clearing methods that exist on different platforms, if they exist. Let's add the next couple of lines that indicate the processing has completed. Alright, our ported program is looking great so far. Let's go ahead and test. We already know this part works, but let's go ahead and answer these questions. My name is Vicky. My favorite color is purple. My favorite animal is an alligator. Now it's thinking manned. It worked. It felt like approximately 1 second between each dot, and our program is nearing completion. In our QBasic program, looking at the rest, it's just time to print the prediction. Let's go ahead and write that. Uh-oh, syntax error. Do you see what happened? We exceeded the max line length and, when we hit enter, it assumed that the line we finished typing on was what we were trying to put in, and it didn't make sense. There might be a way around this, but let's use this as an opportunity to explore line numbers a little further. It looks like line 170 will reach past the word encounter, so we'll go ahead and type up to that point for line 170. We will drop down onto the next line to continue this statement, making sure we end line 170 with a semicolon. In this case, we're not going to go to line 180. Moving to line 171, here, is not a problem because the chances of ever having to add a line between here, instead of just retyping 171, is already pretty minimal. Let's go ahead and continue with the rest of the prediction. We're almost there. We just have a couple of more lines to go and we'll be all set. This is another line that we need to change because a lot of the basic variants do not support the enky variable. So, here's what we'll do. It's a 230 sandwich, right? Believe it or not, this is a loop. Let's break this down a little bit. As you know, we start with 230 as the line number. Our next block in this line is get $. What this does, similar to enky, is it reads a single character from the keyboard and stores into $. It doesn't wait for enter, such as input, just the next keystroke. We then have a colon, which tells the interpreter that a different statement follows this one. The next block is an if statement which checks if $a is empty. If it is empty, no key has been pressed. If it is empty, the 230 at the end tells the interpreter to go back to line 230, or start over on this line. If it's not empty, because a key has been pressed, it will continue on to the last line in the program. I didn't point it out in the last video, but I wanted to point it out here. This command, where it's at, is basically pointless. It was included in the prior video as to show that you could use this command to end execution, but if it's at the end of the program already, the program will end there whether it's there or not. Since these earlier machines could be limited on space and memory, this is superfluous. Let's go ahead and remove it. There is our ported program. Let's go ahead and run it. Alright, it's asking for input, so let's do that. My name is Vicky. My favorite color is purple. My favorite animal is an alligator. Now it's thinking. Voila! It ran my program and I have a fortune, albeit the same fortune as the last video, and still curious if, and how, a purple alligator will bring me a new friend. I need to buy a purple scarf, just in case. Before we go, one cool feature of the Commander X16 BASIC is that we can save our programs. Most of the older systems couldn't do that, but let's go ahead and do it here. To do this, we type save, and give the program a name, in double quotations. This program we'll call Fortune. After that, we're going to type "8. This tells BASIC to save it on device 8, which is an entirely different video. It gave me the OK prompt, so let's clear and reload just to make sure it saved it. By using new, I just wanted to clear out my code and show you that my program was now gone. We can reload our program by typing the same command, but using load instead of save. And it's back in all its fortune-telling glory. Thank you for coming on this porting adventure with me. It's always so interesting to see the differences on how things work even though it's called the same, BASIC. It's kind of like American English versus British English. The core fundamentals are the same, but there are minor differences in the tones and inflections. I hope you enjoyed watching it as much as I enjoyed making it for you. If there's any content you'd like to see, comment below. Don't forget to like and subscribe. See ya!